4-2, our book introduces us to the binomial probability formula. And a binomial experiment, what it is it consists of independent trials whose outcomes are either successes or failures. P, as you know, would be probability of success. And Q then is the probability of fail. Okay. So P would be successful outcome. What are you looking for to happen? Q would be what outcome you didn't want to happen. Not necessarily always a successful meaning, but what you're looking for to happen. And the other thing you should always know is that P and Q are always complements of each other. So just like if P is 70%, Q then would be 30%. They're always complements of each other. So remember that when you're going into this formula. Because most of the time, it'll only give you one of them. So you compute the other one by taking 1 minus that. Okay, so here's your formula, binomial probability. And this should look familiar right here. This is a combination, NCR. And just to review what those mean, N is your total, and R is the number considered. Okay. P then, we just went over that. P is your probability of success. And Q is your probability of fail. Okay. What is this N and R up here as your exponents? Those N and R's are the same as your combination over here. So whatever N is here, you would put that same N value in for here. And same with the R. Okay. So let's try this. Example, of the new cars in a car dealer's lot, 1 in 6 are white. There's our probability, 1 in 6 are white. Today, 4 cars were sold. That's our N, 4 total cars. What is the probability that 3 of the cars sold were white? That sets up our combination. We have 4 cars, and we want to know if what's the probability that 3 of those 4 cars sold were white. So 4C3. My probability of a white car, we saw that in the first sentence, 1 out of 6. So if I have a 1 out of 6 probability that the car is white, what's the probability that it's not white? 5 out of 6. Okay. And these have exponents. The exponent for 1/6 is R. What was R? R was 3. So I put a 3 there. And 5/6 is to the N minus R, which would be 4 minus 3, which is 1. Okay. But like in the statistics that you've found so far, most of the time the easy part is setting up the formula. The harder part is putting in our calculator correctly. So let's go ahead and try that. If you don't have a graphing calculator, that is fine. Any basic calculator should have the combination. If you don't see it, you can email me or download a graphing calculator app. But you will need a calculator with permutations combinations. So 4C3 times, and I'm going to use parentheses, 1 divided by 6, close my parentheses, to the third, times 5/6 to the first power, but you don't really need to put the first power, equals, and you should get, we're going to use approximation signs, we're rounding, 0.015. So approximately 1.5% chance, and that should make sense. When you're thinking of this problem, only 1 in 6 are white, and I want the probability that 3 of the 4 cars are white. That should be a real low probability that that were to happen. Okay, so let's try another one here, because of course they get a little bit trickier. What is the probability that at least 2 of the cars sold were white? Okay, so what does at least 2 mean? At least 2 means two or more. Okay, so 2 or more, I only have 4 cars. So that would be the probability of 2, or, that means add, probability of 3, or probability of 4 of the 4 cars. So I already have 3, that's right here. So I would need to calculate the 2 and 4. Okay, now before we do that, I want to take a second and go over this again. What's the complement of at least 2? If at least 2 means 2 or more, the complement of that is less than 2. So I could solve this by the complement. I could take 1 minus 0 or 1. Okay, in this case, they'd be the same amount of work. If I did the complement, I have to calculate 2 probabilities and add them together. If I did it as the problem read, at least 2, that's still, again, 2 probabilities, because I already have this one, adding them together. But as you can see, if I didn't have this probability of 3, then this one would be more work, and it'd actually be a little bit faster to do it by the complement, and sometimes that's the case. You want to use the complement to solve, okay? In this case, we don't have to, so let's just go back and do that. So I'm going to do, I already have the probability of 3, so I'm going to do the probability of 2, which is the same thing, I'm just changing R to 2. So I would have 4C2, 1/6 to the second now, 5/6 to the n minus R, which would be 4 minus 2 is 2. And my other one would be 4C4, 1/6 to the fourth, 5/6 to the 0. And then when I calculate those two, I can add all 3 of these together and get my answer. So handy dandy calculator, let's see, I want 4C2, 1/6 to the squared, 5/6 to the squared. And I'm going to get 0.116, 4C4, 1/6 to the fourth, 5/6 to the 0, and hopefully you know anything to the 0 power is 1. And then you get 0.0008, okay? So if I add those 3 together, plus 0.015, I would get this. I would get a probability of 0.132, right? That's my answer. At least 2 of the cars were white would be a 13.2% chance probability. Okay, let's try another example. At a small college, 1/3 of all students are vegetarians. There are 5 students in line at the cafeteria. What's the probability that all 5 students are vegetarians? Okay, so this is my P, 1/3. This is my N, because there's 5 students in line. I can't have more than that. And the R that I'm asking is 5. I want all 5 of the 5 students. So setting up my formula, I would have 5C5. The probability of someone being vegetarian is 1/3. So the probability of not being vegetarian would be 2/3. This would be to the 5, this would be to the 5 minus 5, which is 0. And I could calculate that out, 5C5. And then 1/3 to the 5th. And again, anything to the 0 power is 1. .004. And that should make sense, right? If only 1/3 students are vegetarian and all 5 would by chance be vegetarian, that should be a really small percent. What's the probability that just one of the students is a vegetarian? Okay, so what changed is my R. My R now is 1. So my formula would be 5C1, one of the 5 students. My P, again, is 1/3. My Q is 2/3. But now my 1/3 is to the first power. My 2/3 is to the, what's 5 minus 1? 4. And I calculate that. 5C1, 1/3 to the first power, 2/3 to the fourth power, 0.329. So almost a 33% probability that one of the five, and it should be a higher probability. Okay, maybe just a couple more here. Ellen plays 8 hands of a card game with her friends. She has a 1 in 3 chance of winning. There's my P. What is the probability that she will win exactly half of the hands played? So my N was right here, 8 hands, right? That's the total hands I'm playing. I want to know what's my probability of winning half. So half of 8 would be 4. So my combination would be 8 hands. I want to know the probability of winning 4 of them, half. P would be again 1/3. So again, Q would be 2/3. 1/3 to the fourth power, my R. 2/3 to the, what's 8 minus 4? 4. And then I grab my calculator. 8C4, 1/3 to the fourth, 2/3 to the fourth, 0.171. Good. Let's do one more. In a lottery, each ticket buyer has a 1 in 10 chance of winning. There's my P, your probability of success, 1 out of 10. If Chip buys 10 tickets, there's my N, my total number of tickets, what is the probability that he will win at least 1? Okay, so this is a good one because here's the at least problem. If I wanted to figure out the probability of at least 1, that would mean 1 or more, which if I have 10 tickets, I would have to do 1, 2, 3, 4, all the way up to 10. That's 10 probabilities to calculate with a combination. That would be a lot of work. The opposite of at least 1 is none. So if I do the complement, 1 minus none, that gives me at least 1. So in this case, I only have to do the probability of 0, none. And then take 1 minus that, and I get at least 1. So if I were to do 0, that would be 10, C0, 1 out of 10 to the 0, 9 out of 10 to the 10th, 10 minus 0 is 10, and I'm going to take 1 minus whatever that equals. So on my calculator, 10 10C0, 1/10 to the 0, anything to 0 power is 1, and 9/10 to the 10th. 10C0, 1/10 to the 0, 9/10 to the 10. Okay, so I'm going to do 1 minus 0.3487. Right, I'm going to round more so it's pretty accurate. So 1 minus that, you get this, 65.651. Approximately, right? We're rounding. Okay, so at least 1, right? If he buys 10 tickets, at least 1 will be a winner. That's about 65% chance, and that sounds correct. Okay. All right, so your homework is on Blackboard Learn. If you go back, you should see, we just did the notes. Here's the worksheet, 4-2 worksheet for Part A. Okay, and here's your formula. And you're just going through just different types of probabilities here. I think there's 10 of them total. Okay?